All right, great. Um, can everyone hear me? Hopefully. Theo, let me know on the moderator chat if you can't. This is Sarah Miller. Thank you all for attending. I know this wasn't how we wanted to get together and engage today, but I think the organizers have done a great job throwing together this virtual conference in just a matter of basically 48 hours. So thanks everyone for attending. We've got some great research. Mike Murto from University of Michigan is up first. So Mike, take it away.
Sure. So I'm going to start sharing. So hopefully everyone can see my slides. So this is joint work with Martha Bailey and Alfia Karamova, and we're going to be looking at the determinants of life expectancy in the 20th century. I'm going to go ahead and jump right in. So to start off on like a very broad overview, an empirical trend that I think we've all become familiar with in literature recently is the income distribution, which narrowed substantially in the mid-century in the United States before widening over the latter quarter. And so I think a natural question in economic demography is, has there been a similar trend in mortality? And besides the reasons that we might care about mortality directly, it also is a reflection of things like quality of life and access to healthcare, behavior that promotes well-being, and hence some differentials in mortality, or if we observe differentials in mortality, this sheds light on these differences in quality of life and access to healthcare for different groups of people. And so this research, empirical research, really started with Kitagawa and Hauser's 1973 study, which used the 1960 census linked to death records, and they documented for the first time significant mortality differentials across education and income groups that were larger for women in terms of education. Just to quickly summarize, there was a lot of subsequent literature that confirmed this finding of positive differentials across socioeconomic status, and actually evidence that seemed to suggest that these differentials were increasing over time. So just to read this graph here from left to right, the Kitagawa and Hauser there, you see that blue dot for men, that represents that men who are in the lowest education group had mortality rates that were 50% higher than men who were in the highest education group. And as we move to the right across time, these studies, subsequent studies, found positive differentials and actually increasing into actually the 2000s. There's a recent paper by Chetty et al., which looked at income differentials across mortality and documented that this differential continues to exist and increase across just the first 15 years of the 21st century. So in this paper, we're going to be looking at birth records that are from early 20th century cohorts that are linked to the 1940 census and then subsequent death records. And rather than looking at mortality, like a lot of these previous studies have looked at, we'll be using complete measured longevity, capturing the total length of life that was lived for these early 20th century cohorts. I think in terms of demography, one thing that you sort of a lot of people are familiar with is this is similar to the difference between cross-sectional fertility and then the total number of children that a woman has. So if they're rapidly changing behavioral effects across time, these could give you two very different answers. And similarly here, if there are changing effects on mortality across time, then looking at the complete longevity of a few cohorts will give you a different picture, and perhaps one that's more directly applicable to the life and well-being of those people. So our data, we're going to use data from North Carolina, which is a state that also has a significant Black population, making it possible to do analysis of some Black-white differences in this socioeconomic status gradient. And just to preview our results, we don't find any evidence for longevity differentials across education for men, but we do find a consistent pattern of positive differentials for women, with about on the range of about an additional year of school being associated with an additional half year of life. Our data are using the data from the LifeM project here at the University of Michigan. And so these are data that take a random sample of birth records and then link those to death records and census records, as well as of a variety of other vital statistic records. But those are the two that we'll be using in this paper. And just two brief bullet points on this. Our LifeM data, the death record coverage very closely matches the vital statistics. So we don't think we're getting a skewed, we don't think we're polling from a skewed sample. And our sample comes out to almost 1,500 records which are linked to the census, a little over 1,100 that are linked to death records, and our final sample will be drawn from these 7,400 which are linked to both. The link rates across cohorts, link rates to the census for men are pretty consistent. And if you do historical linkages, these are actually pretty good numbers for link rates. From our sample, we get about 60% in the early cohorts, and that varies between 40 and 60% for all male cohorts linked to the census. For death records, there is this decline across time, which you might expect. Some of these later cohorts are probably still alive, as at the end of our sample that we're getting drawing from the death records for. For women, this is also a common thing. If you do historical linkages, it's a little more difficult to link women to different records because they have a higher probability of changing their name. But we still get between 40 and 50% of women in these early cohorts linked to the death records, and between 20 and 40% linked to census records. And both of these decline over time. But we're pretty happy with these link rates. And in terms of the underlying sample, we can compare these samples to the 1940 census. And they are a little different. They tend to be a little younger, tend to be a little more educated and a little higher family income. And so to deal with this, we're also going to do a reweighting exercise, which I'll explain more about in just a second. We're going to do basic OLS regressions for our main results in this. We'll be regressing the age of death, that is the completed longevity for individuals, on a measure of their socioeconomic status. We do both education and family income. In this presentation, I'll be only presenting the results for education. And then we do add various controls. We have fixed effects for the county of residence in 1940, as well as birth year by race fixed effects. And in some specifications, we add time varying county controls that attempt to account for access to healthcare. And those would either be an indicator for the presence of a hospital or the number of beds in medical facilities in that county. And as I mentioned, we do reweighting exercises, and these are based on the inverse probability weighting documented in Bailey et al., which is a translation of the earlier work by Gennardo et al. So beta here is the coefficient of interest that I'll be reporting. So jumping straight in to our results, these are the results for all men, education, and we actually add our controls sequentially here, but I want to draw your attention to the third and fourth column. The third column here is when we have our full set of fixed effects, county fixed effects, and birth year by race fixed effects. And then the fourth column repeats this, but reweights the sample to look more like the 1940 sample, the 1940 census rather. And the consistent story across the board here is that these are really quite small numbers, and none of them are significantly different from zero. Each of these are saying that an additional year of school is associated with, at most, maybe an additional 10th year of life. And we also break out our results by race. For white men, these are very similar to the overall male numbers, very small numbers, very close to zero. Not a whole lot of a story here going on with a differential across this particular measure of socioeconomic status. For black men, we do see larger point estimates, especially after a reweighting exercise, but these point estimates tend to be noisy. Still, after our reweighting in our fourth column there, you'll see an additional year of life associated with about an additional an additional year of education associated with about an additional 0.4 years of life. Women, as I mentioned, we find a consistent positive effect. So again, drawing your attention here to the third and fourth column, you see that an additional year of education for women is associated with about an additional half year of life. And this is a pretty strong relationship. And similar magnitudes for white women again here. For black women, slightly smaller estimates and noisier, but still you can't reject, these aren't statistically different from zero, but neither are they statistically different from the overall population. So just to contextualize these results a little bit, the existing literature, that is the literature that started in 1973, documented these large and increasing differentials for men across educational groups. And Kitagawa and Hauser also found a larger differential for women than men, which we find as well. We find a positive differential for women, but nothing for men. Subsequent work documented a decreasing differential, that is a narrowing of the inequality and mortality rates for women before it started to increase again over the last 20 years in the 20th century. So in the context of this literature, our findings are consistent with the story that there was a smaller relationship between socioeconomic status and mortality for earlier 20th century men, but this substantial relationship existed even in the early 20th century for women. So I think also a natural question here, this is a linking exercise. So is it possible that selection is driving these results rather than any type of real underlying relationship? So this is something that we've taken seriously and we've tried to approach in a few different ways. And so I'm just going to talk through quickly here what we've done. There are two main approaches that we've taken, one of which is we can think about the sample that we've linked to the 1940 census, but not death records. You recall we have a 7,400 individuals in our full sample, but more like 1,400 which are linked to the census. So we can use those who are linked to the census for whom we have accurate socioeconomic status measures, but aren't linked to death records as the unselected group. On the flip side of that, we can also take the entire underlying 1940 census and think of this as a sample of people who aren't linked to either death records or the census. That might sound a little confusing because it's the 1940 census, but remember, we're starting with birth records, which are linked to the 1940 census. So these are the unlinked individuals. But the bottom line across these groups is when we've done different selection exercises, I think the ones that I have in tables here for are Heckman selection exercises. It's selection alone isn't enough to explain the results that we're getting. For men especially, we still find almost null results. There seems to be a little bit of negative selection, but it's not enough to explain this full effect. That is, they're still significantly different from the Kitagawa and Hauser effects results. So just to wrap up here, in this paper, we've documented for early 20th century cohorts, for the first time really looking at this part of the century, very small associations between socioeconomic status and longevity for men, in contrast to literature from later in the 20th century, which found significant positive differentials. But we do document strong positive associations between education and longevity for women. And these are actually in line, similarly sized relationship with what is documented in the Kitagawa and Hauser paper. And while selection is an important consideration and something that we take seriously, we don't think that our results are primarily driven by selection into the linked sample. And so for next steps, we hope to look at similar associations for children, that is, education of their family probably rather than their own education, since their education is likely not complete by the time the 1940 census rolls around, and also family income for those cohorts. And similar to an exercise that's done in Petty et al., they have very rich tax data, and they're able to look at the association between these mortality differentials and local area characteristics, and document that there's significant heterogeneity in different places of the country. And we'd like to look and see if those heterogeneity across local areas existed early in the 20th century as well. We're still working on this, but just to give you a small flavor of what this is going to look like, hopefully, is something like this, where we can split our sample by individuals into either the top or bottom third or quartile later of educational, of their socioeconomic group, and then look at the association between that and these local area characteristics that we can measure. And I would especially point out here this proportion of high school, very highly educated people. There doesn't seem to be any significant association between their own longevity and their community that they're living in. But for people who are in the lowest group of education, there seems to be a positive association from living in these areas with a high amount of educated populace. And this is a finding that's consistent with the later literature that's documented in Chetty, although the measures are a little bit different. But this is something that we hope to push on forward, moving forward. So I also have women here, but these are noisier estimates that we're still working on. So thank you. And I look forward to any questions, comments, suggestions. If you want to ask them now, I'll try to tackle them. And then also, you can email me. There's my email. So thanks.
Great. Great job, Mike. If anyone has a question, if you submit it under the Q&A feature, we can ask Mike to ask it now. And I guess I can start off while you guys are typing. One question I have for you is, do you have any information on the birth record that could help you characterize people who aren't linked to either the death records or the 1940 census? Because it seems like that's another dimension on which you have a lot of potential selection.
Yeah, there's very little information on the birth records. We have things like sex, but we don't always even have information about the parents. So I think that's a limitation. That would definitely be something that, a different area where selection into the linked sample might be exploited, but I think we're just sort of limited by the data there.
Great. Any other questions? If you're still thinking of them, we can also catch up in the end to ask more questions. I don't see any submitted on Q&A. Yo, do you see anything I'm not seeing? Okay. I guess I'll just ask one more question then, since we have a couple minutes, Mike. The Chetty paper found really huge difference in life expectancy across income distribution, about 15 decade and a half of additional life for people at the top versus the bottom. And you're finding, that was for men, you're finding almost nothing. So do you have any theories about what is going on with men over the course of the 20th century that has resulted in this like wide opening up of inequality in terms of life expectancy?
I have some speculation. Nothing that's
Go for it.
on a data, but things that I'm actually hoping to pursue in future research. But one of the things that you might imagine would compress this type of mortality differential, in actually a similar way that existing literature suggests would compress the income distribution, would be things like unions, which would support men, especially who in the 1940s would have been involved much more heavily in unions and the labor force in general. But giving them access to things like healthcare or certain benefits that they wouldn't have otherwise. And so this period of higher specialization, and then also the decline of unionization rates through the 1950s and 60s could be a partial explanation, I think, in terms of this increasing differential. Then, in the same way that the Card paper and others have documented an increase in the income distribution that's attributable to the decline in unionization rates. So that is speculation on my part, but it's something that I think we hope to look into moving forward as we sort of gather data that's can appropriately answer that question.
Great, that's super interesting. And I should say, I see in the Q&A, Martha, noting about the selection that you have compared the linked sample to the 1940 census. And so that's one way to examine the selection as well. So, so great. That's really, really helpful. Okay. Other participants, if you want to, if you think of a question for Mike later throughout the session, you want to submit it to Q&A, it's no problem. We'll have a little bit of time at the very end for questions. Otherwise, I'm sure we're all clapping for Mike at our computers. Thanks, Mike. Next, we have Olga from University of Kentucky. So if Olga, if you could share your screen, we can let us know if you have any technical difficulties. Great.
All right, can you see my screen?
Yeah, looks good.
Okay, great. Thank you for having me. So I'm presenting a paper on the effect of delaying retirement on mortality. So the relationship between work and mortality is important for both developed and developing countries. And for developed countries, there are concerns about fiscal sustainability of pension systems because the share of the elderly population is growing relative to the share of the working age population. and many countries want to provide incentives in order for individuals to delay retirement. But we also need to think about a potential cost or benefit, depending on which direction it goes, the potential effect of working longer on health. And in this paper, I'm just going to be talking about mortality. And in developing countries, there has been rising concerns about providing or establishing social security programs and public pension programs. And the reason for this is that it could provide more equity in these countries. And a potential benefit or cost could be, depending on which way the effect goes, is its effect on mortality. If once these countries provide pension benefits, individuals work less. So the literature effect of work and mortality has mixed results, and most of the literature concentrates on developed countries. And also it concentrates on reforms that made early retirement possible. And these reforms mostly focus on very specific groups of individuals, such as, for example, individuals in the military, which may provide some concerns about the identification strategy, that the results are too specific to a particular group. And also there are papers on the effect of increasing the normal retirement age, which may make the individuals to shift their retirement to a later forced way, and not in a voluntary way, where you may want to figure out what's the effect of working longer if individuals are choosing kind of more voluntarily based on their preferences of health, whether they should work or not. And a lot of these studies are on short-run effects, and we are also interested in long-run effects. And this study evaluates the effect of a 1964 reform in Soviet Russia that provided financial incentives for older individuals to work longer. And before this reform, individuals who are eligible for a pension, if they worked, they could keep about 30% of their pension. And men became eligible for pensions at age 60, and women became eligible for pensions at age 55. In an effort to increase its labor supply, the government decided to allow individuals to keep a greater share of their pensions if they continued working once they reached pensionable age. And on average, after 1964, individuals could keep 56% of their pension. And in my paper, I show substantial increases in employment rates in response to this reform, providing a first stage for the paper for this current paper. And this graph shows difference coefficients for the treatment group, which are eligible the 1964 reform, and the control group for individuals who are not eligible for this reform. As you can see, there were parallel trends in employment rates between the treatment and control groups before the reform. However, after the reform, there was a jump in employment rates in the treatment group relative to the control groups. So individual pensioners really increased their employment rate substantially by 47% by 5 years after the reform started. So this study makes several contributions. First, it evaluates the effect of delaying retirement, whereas the previous literature mostly focused on the effect of providing early retirement. And also it evaluates a reform where delay is more voluntary, and which is in contrast to a reform that raises normal retirement age, where it's a lot less voluntary. And also this study is relevant for developing countries, and currently literature mostly ignores the effect of pension reforms or working longer in developing countries. And it could also be relevant for blue-collar workers in developed countries today. So this is because older workers in Soviet Russia in the 1960s were lower educated. Only about 3% of them had a college degree, and they were mostly working in manufacturing type jobs. And also historical vantage points allows me to trace out mortality rates for 12 years after turning pensionable age, which allows me to identify long-run effects of working longer. So to give you some background on Soviet Russia in the 60s, the pension replacement rate was about 64%, which is similar to those in OECD countries today, health insurance was provided to everyone, and life expectancy was about 16 years at pensionable age. It was higher for women and lower for men, as it still remains today. And the labor market was relatively free in terms of workers could choose where they worked, how long they worked, and things like that. And that probably explains why I find such large effects on employment rates of producing these financial incentives. So to answer this question, I had to compile a data set on Soviet mortality vital statistics. So I collected administrative data from the archives in Moscow. So these are reported on tabulated and standardized reporting forms that are submitted by each oblast. And an oblast is like a state, and there are 73 of them in my data set. And these data include the number of deaths by age, oblast, gender, and the urban-rural status. And I've collected data from 1956 to 1976. And finally, because I'm interested in mortality rates, I've also collected data on the age distribution of the population from 1959. And I've also smoothed these data in order to address age heaping at round ages such as 60 and 55. And I've adjusted the population counts from 1959 for my entire period of analysis from 1956 to 1976 using the annual number of deaths. And this is an example of reporting form. So the Department of Population and Health Statistics produced these, and this has been declassified after the Soviet Union collapsed. Before, it was all secret and nobody could get access to these documents. The rows are the ages, the columns are the number of deaths for men, women within urban and rural areas, and this particular page is for 1958 in Arkhangelsk Oblast. And the back of the page, which is the source of my data, represents ages 45 to 100, and as you can see on the bottom is signed by the head of the statistical office in Arkhangelsk Oblast. So these data are a compilation of individual records that each oblast statistical head had access to from each of the death filings. So kind of these official records were all compiled by each statistical agency and then sent to the central government. So I think these are really reliable data. Unfortunately, I don't have individual level records. And this reform both changed financial incentives through obviously an increase in individuals in their work duration, and also this reform increased the income of individuals because now they both receive their pensions and income from working. So, and the direction of both of these channels is ambiguous. And to talk more about potential behavioral changes after the reform, or just potential behavioral effects of working longer or mortality. So, for example, if individuals work longer, they may have more time to invest in more healthy behaviors, such as exercise or cooking healthier foods, and that may reduce mortality. However, individuals may become more sedentary, and that may increase mortality. Or individuals may choose to consume more harmful substances, such as alcohol and tobacco, and that may also increase mortality. Or also, it's important what type of work individuals are leaving. So if individuals are leaving very difficult jobs, such as a coal mine job, then working longer perhaps may increase their mortality. So my empirical specification is an event study specification where my dependent variable is the mortality rate in the particular oblast for a cohort born in 1 year and an event time t. And my event time is measured in years since turning pensionable age. So it is 0 at age 60 for men and 0 at age 55 for women. And my treatment group, my treated cohort, is a cohort that turned 60 in 1964 and afterwards, and my control comparison cohort is a cohort that turned 60 before 1964. So just to give you a quick picture, so my data is at the age of death, and I convert that into kind of a birth year label, and the birth year label 1902 corresponds to a cohort that was age 61 to or 62 in 1964. So I hypothesized that these individuals were less likely to be affected by this reform because they've already spent 1 or 2 years in retirement if they chose to retire, and then perhaps it's harder to go get back to work once you have left work. So these individuals could be partially affected by the reform, but still less affected than individuals who are just turning pensionable age as the reform is starting. And the cohorts born in 1903 and 1904 are my treatment cohorts because they are 60 or below in 1964. And as for younger cohorts who say are 56 or 57, 57 or 58, in 1964, I presume that there could be some anticipation effects for them. They can prepare for this reform in advance, and perhaps they may adjust their employment rates and also mortality rates even more. So here is descriptive evidence of the effect that I find in the paper. So this shows the evolution of mortality rates among treatment and comparison cohorts. So the red solid line shows my comparison cohort, and event year 0 is age 60. So you can see that for negative event years, that's years 54 to 60, the treatment and comparison cohorts, mortality rates evolve in a parallel fashion. However, after age 60, you can start seeing the treatment and comparison cohorts start trending differently, and there's a gap between them that shows that the treatment cohort that worked longer was most affected by the reform has an increase in mortality rates relative to the control cohort. And here the regression coefficients are control for covariates, and again, the pre-trends are parallel. Can be seen by the 0 and not statistically significant different coefficients in the negative event years, but the coefficients are positive and statistically significant in some years after turning 60, and it looks like the effect of working longer seems to be gradually going up over time. So by 11 years, in event year 11, so by age 71, it looks like the mortality rate is 0.8 percentage points higher among the treatment cohort than among the control cohort. And this is a picture of the same picture as before, except for now the treatment cohort is born in 1904. So this cohort is a year younger and perhaps had a little bit more time to adjust their behavior, but you can see the same pattern as for the previous treatment cohort, and these are the regression coefficients that show the treatment effect, and the magnitudes are bigger, and the positive trend seems even more evident here, and I think that's because this cohort had more time to adjust their behavior, and I kind of keep seeing that as I look at younger and younger cohorts. So for women, my treatment and comparison cohorts are defined differently because women became eligible for pensions at age 55 relative to age 60 for men. So the comparison cohort for women is born in 1907, whereas my treatment cohorts for women were born in 1908 and 1909. So my treatment cohorts are 55 for age 55 before 1964, and my comparison cohorts are age 55 after 1964. And this graph shows the evolution of female deaths across the treatment and comparison groups before and after turning age 55. Now my event year is equal to 0 at age 55. So you can see that, I mean, there definitely doesn't appear to be an increase in mortality rates among women as a result of this reform, and these regression coefficients show that there are parallel trends in mortality rates before turning age 55, and the coefficients really jump around after age 55 through age 71, but I can't make any much of a conclusion about an effect of working longer on the rates for women. So to summarize, I find long mortality rates among men after a delay in retirements. There was a 7.4% increase, at age 63, and this increase continues through age 72, and I find that there's a 36% increase in the mortality rate at age 72. I don't find an increase in mortality among women after a delay in retirement. And one of the explanations for the gender difference could be that men are employed in more strenuous occupations than women. Perhaps welcome any other explanations. And I'm working on assembling data on deaths by causes of death in order to get more at the mechanisms of what's going on here. And so this is it. Please email me if you have any questions.
Great. Great job, Olga. That was really interesting. So put your questions into Q&A. I can start off with a question. I think the difference in the patterns between men and women is just really interesting and striking. I wonder, could you look at different oblasts that had different specializations in different types of industries to sort of see if you can identify some of these industry-specific or occupation-specific kind of things that are associated with higher mortality? Is there sort of regional specialization you could take advantage of there?
Yes, I can look into this. So for example, in the Far East or in Siberia, there's probably a lot more mining than in other areas, so I can look into that. Of course, these regions may also be different, but I can see if there's more of an effect in regions that have harder occupations. That's a good suggestion. My only worry is that they may also be different in other ways that affect mortality, but it will be very interesting to do an analysis like that. Thank you.
Great. So any other questions? It's like we don't have any questions at this time, but if you guys think of another question for Olga, just put it into Q&A box and we can revisit this at the end of the session. So really interesting, Olga. Thank you so much. Next up, we have Ajin Lee from MSU. Ajin, if you could try to share your screen and sure that works.
Yeah, sure.
Awesome. Okay, great. Take it away.
All right. Thank you all for being here. My name is Ajin Lee. I'm at Michigan State, and this is a joint work with Boris Babson at Harvard. To start, I want to motivate my study by looking at a recent trend in the U.S. government. The U.S. government has been increasingly providing public health insurance benefits through private firms. For Medicaid, which is the focus of my paper, it is a movement from the traditional fee-for-service program that is administered by the government to Medicaid managed care program administered by private firms. This figure shows that increase in the share of Medicaid beneficiaries enrolled in private firms to receive Medicaid coverage. You can see that the number was about 40% 10 years ago, and now that's over 70%. You can see the same pattern if you looked at the share of Medicaid expenditures that go into private firms. So I want to start by talking about the main differences between the two systems. I want to highlight two differences. The first one lies in its payment system. So under the public system, which is called the fee-for-service or FFS, the government essentially directly pays healthcare providers for each claim that they make. Under the private system or Medicaid managed care, the government pays private plans a fixed fee per month per enrollee, and private plans are responsible for reimbursing healthcare providers. So the thought is this fixed fee structure can incentivize health plans to reduce costs. But it's unclear whether this cost reduction incentive could lead to reduction in the quality of care or a distortion in the distribution of the quality of care. You can imagine private plans having an incentive to keep relatively healthy enrollees in their plans, so maybe they would invest more in the healthy, low-cost individuals while shirking on high-cost, more expensive type of enrollees. The second difference lies in its healthcare delivery system. So the fee-for-service public system gives beneficiaries maximum flexibility, and it does not actively coordinate nor restrict care. Under the managed care system, the private system, each beneficiary gets assigned a primary care provider who serves as a gatekeeper and a care coordinator. You can imagine where, under managed care, you might have, restricted access to more specialized care or more expensive care. But at the same time, you would have a usual place to get routine type of care, and you would have a primary care physician assigned to you whom you can see whenever you need to get any sort of usual type of care. So you can see the welfare effects of Medicaid privatization are ambiguous. So what we want to do in this paper is to examine the effects of Medicaid privatization on quality of care as well as beneficiary satisfaction. Existing literature has paid limited attention to these sort of outcomes, such as quality of care or beneficiary satisfaction, due to basically two reasons. The first reason is that there's limited data availability on private Medicaid. As you can imagine, if you were to collect some sort of uniform set of claims data from multiple private firms, you can imagine how it would be difficult to do. And the second reason is that it's difficult to measure beneficiary satisfaction or quality of care in health in general through administrative data. So what we want to do in this paper is to overcome these previous challenges using some of the new ways in approaching the question. So the first thing we do is to use a rebuild preference framework in measuring beneficiary satisfaction. So what we'll be doing is to look at beneficiaries' relative likelihood of Medicaid attrition under public versus private Medicaid. So our key assumption here is that we're assuming beneficiaries are voting with their feet, with higher attrition reflecting lower degree of satisfaction. We think that looking at Medicaid attrition is important in its own right. First of all, a lot of Medicaid beneficiaries end up leaving Medicaid or losing Medicaid benefits. In our sample, about half of infants who received Medicaid at birth stay on Medicaid by the time they turn 2 years old. And we know that Medicaid has several positive outcomes in the future. So we know that it's correlated with increased health, educational attainment, as well as adult earnings. So in terms of addressing the potential endogeneity in participation into public versus private Medicaid, we exploit an exogenous source of variation focusing on New York infants. So in New York, Medicaid infants weighing less than 1,200 grams were initially excluded in participating in managed care plan, and they were instead required to be in fee-for-service for the first 6 months of their life. So essentially, this figure summarizes the variation we're going to be using for this paper, which is plotting managed care enrollment at birth among Medicaid infants. And you can see that according to this policy, infants born below the 1,200 gram threshold, essentially there are very few infants enrolled in managed care, whereas if you look at infants above the threshold, there's a discontinuous increase in managed care enrollment patterns. But we're going to be using this variation in an RD design, basically, to study future Medicaid attrition patterns. And we're going to be using a unique set of data sets covering all public and private Medicaid claims for New York infants that are longitudinally linked to their original birth weight. So just to go over our conceptual framework very briefly, we're basically going to assume that children receive either fee-for-service or Medicaid managed care at birth based on their birth weight. So this is our treatment variable or the instrument indexed with Z. We're going to assume that it's essentially random. And in the following period in the future, families are going to make enrollment decisions indexed by D. So you can make one of three decisions. One is to stay on Medicaid, or you can leave Medicaid and enroll in a private insurance plan, or you can leave Medicaid and become uninsured. So we're going to assume that every children in our data starts with having Medicaid, just that they have either fee-for-service or Medicaid managed care. And each family has utility U that depends on quality of care as well as cost of care. And, standard assumption, we're going to assume that utility increases in quality and decreases in cost. The family is going to make an enrollment decision that maximizes their utility, and given this simple conceptual framework, we can see that Medicaid privatization may reduce Medicaid attrition if the utility of staying on Medicaid when you're given the managed care assignment is greater than utility of staying on Medicaid under fee-for-service. And there could be two channels through which this can happen. One is through higher quality, and the other is through lower cost. So we're going to focus on transaction cost of enrolling here because medical cost under Medicaid is essentially free under both fee-for-service and Medicaid managed care. And what I want to argue today is that our results are consistent with a higher quality mechanism, and we're going to try to rule out this alternative transaction cost mechanism. So moving on to the result, this is the graph I showed you earlier, basically plotting managed care enrollment at birth. You can see that there's a huge jump above the threshold. And given that the policy stated that these infants below the threshold would be excluded for the first 6 months of their lives, if we follow them up and look at, say, managed care enrollment at 24 months, we basically find that this discontinuity disappears by the time these kids turn 2 years old. So to learn more about what happens over time, what we do is to estimate this RD model at each Ajin month. So each dot here is an RD estimate from a different regression, along with a 95% confidence interval. And what you can see is that, consistent with what we saw just now, at birth, there's about 50 percentage point difference in managed care participation. That lasts for up to almost 2 years, as you can see here in the pattern. And by the time the kids are about 24 months, we can find that there's basically no difference in the managed care participation at the threshold. So what this is telling us is that the exclusion based on birth weight essentially generated differential Medicaid managed care participation for up to 2 years. So this was a quite significant amount of differential exposure. And in terms of the total number of months enrolled in managed care, we find that by the time these kids turn to 2 years old, there's about 8 months difference in the amount of managed care exposure between these infants below and above the threshold. This is the main sort of graph, main result shown in a graph, basically looking at the probability of Medicaid participation, again, at each Ajin month. And what you can see here is that during the first year, there's basically no difference in the probability of Medicaid participation between infants below and above the threshold. And starting 12 months, you start to see this divergence in Medicaid participation at the threshold. And basically, you can see about 20 percentage point higher Medicaid participation for infants above the threshold throughout the period of time we can observe them, which suggests that exposure to managed care in early life essentially increased future Medicaid participation. In terms of the total number of Medicaid participation, we find that the difference becomes to show up around 12 months, but then the number becomes significant, roughly around 48 months, which is about 7-month difference in Medicaid enrollment, just based on whether you were born below and above the threshold. So our thought is that this is driven by improved quality or beneficiary satisfaction. To provide more consistent evidence to that story, we look at several measures of quality. So here you can see the RD estimates on preventative care claims and spending, as well as office care visits, and so on. So what you can see here is that children born above the threshold and thus were more likely to get managed care, they tend to have about 0.7 more claims within the first 6 months of their lives, and also which translates into about $10 more spent on preventative care. And we can see that these kids also spend about 1 more office visit during 6 months, all driven by a primary care physician. We find no difference in specialist care, and this 1 more visit translates into about 20 more minutes spent in office. So this is consistent with the idea that under managed care, these kids have a usual place to get care from, and they might be able to get more preventative care and routine care than the ones put into the public plan at birth. We find no change in inpatient or ER visits, suggesting that there's no difference in terms of no difference in serious type of care they would need when in adverse health events, and the difference, if anything, is coming from this preventative routine care margin. To further strengthen this mechanism, we look at heterogeneity by maternal exposure to Medicaid prior to childbirth. So if beneficiary satisfaction is in fact driving our results, we would expect to see greater effects among families who are more sensitive to the quality of care, who are more conscientious about the type of care children are getting. The one proxy we're using here is to see whether mothers who were were exposed to Medicaid system prior to childbirth, and their children are more likely to stay on Medicaid when they're put into managed care plan as opposed to fee-for-service. And as you can see here, when we look at future Medicaid participation patterns, the effects are solely driven by children whose mother had above median exposure to Medicaid prior to birth. So this is consistent with our story that, beneficiary-driven, demand-driven effects are explaining our attrition patterns. To rule out alternative mechanism, we consider potentially private health plans helping to reduce transaction costs enrolling in managed Medicaid. We consider two proxies for baseline transaction costs. So one is family size, the other is urban residency. I'm just going to show you the effect by urban residency here. The idea is if you lived in urban areas, you might have faced relatively low transaction costs. So if it's the transaction costs driving our result, we would see larger effects in relatively rural areas. So we look at children living in New York City versus other counties. And somewhat surprisingly, we see that the effects are much stronger in New York City, suggesting that this lower transaction cost story is unable to explain our pattern. And relatedly, you might expect to see health plans trying to selectively retain profitable enrollees, less costly, more healthy enrollees. So we look at whether the effects are driven by child's expected cost of treatment. And it turns out that if anything, the differential Medicaid participation patterns are coming from children with above median expected costs, suggesting that it's not driven by health plans trying to cherry pick relatively healthy individuals. To sort of validate or complement our RD approach and to think about generality, we use an alternative source of variation, basically using the county by count rollout in the managed care participation mandate in New York State. And I'm just going to show you this difference in difference estimates by birth weight groups. So what you can see here is that the effects are solely driven by this low birth weight infant. So on the x-axis, you have birth weight. On the y-axis, these are just different diff estimates, which sort of helps us understand what is going on. So DD produces consistent results for low birth weight infants, but no effects elsewhere, suggesting that attrition effects are unlikely to reflect cherry picking or crimp scheming by health plans, because these are, if anything, more costly, less healthy individuals. Also, it's not consistent with a reduction in transaction costs. Given that these are babies with very high expected cost of treatment, you would expect that the underlying transaction costs would be low for these high cost, low birth weight babies, but we see that effects are essentially driven by them. So what we think out of this is that our results come from relatively sicker enrollees who are sensitive to the quality of care. So what do we learn about the value of Medicaid? Our effects are pretty large. I didn't show you the two-stage least square estimates, but what we get here is that assigning Medicaid managed care to our sample of infants at birth increases Medicaid enrollees by about 52% by the time they turn 4 years old. This is large, but fairly consistent with other previous estimates using different ways to increase Medicaid enrollment, basically. And the takeaway here is that the value of Medicaid is a function of the underlying quality as well as medical costs, which have been the focus of the literature. What we show is that although these people with higher medical costs value Medicaid more, they might be the ones that are more likely to leave Medicaid once they're put into a relatively low quality program. So to wrap up, receiving Medicaid managed care at birth due to exceeding this birth weight threshold increases the total number of Medicaid by 14 months over the first 48 months, which was that 52% increase. And our results are consistent with improved quality under managed care, increasing beneficiary satisfaction, resulting in higher retention. And finally, we think that welfare effects of Medicaid should take into account the underlying quality of the program, and the change in the delivery system could potentially increase Medicaid retention and participation. Thank you.
Great, thank you so much. That was super interesting. So does anyone have any questions you can put in the Q&A? Okay, I can start off with a question, and then if people have questions, please put them in there. Otherwise, we can wrap up. So one question I have is maybe you could say something about the SSI program, since low-income parents get about $700 a month for babies born under this 1,200 gram threshold. Do you think it could be possible that that could affect like their labor supply or their future eligibility for Medicaid, or do you think that's unlikely to be kind of playing into the results here?
It's a great point. Definitely important to think of that. So one is that SSI, from the previous research, SSI has limited impact on Medicaid eligibility itself, which would be a bigger problem for us. But you're right that SSI provides cash benefits, and that could have differential effects on future Medicaid participation. So we did look at what happens to the probability of living in high quartile, high income neighborhood versus low income neighborhood across these below and above threshold families, and we find no difference there. And also we think that the diff and diff can sort of, to a certain degree, address that potential confounding factor, given that it's unrelated to SSI variation at all. We're just looking at rollout of managed care mandate, and which is not subject to that SSI threshold at 1,200 grams. So we think that SSI is unlikely to play a major role here.
Okay, great. So I don't see any more questions, so maybe I'll just turn on my video at the very end and say thank you everyone for participating. This was really great seeing, I think, fantastic presentations, and I'm sorry we aren't together in person, but I hope pretty soon when this crisis is over, we can all get together and meet in person. So I'm going to go ahead and stop the broadcast, but thank you all so much. This was really